Hey guys, hope you're doing okay, that you are healthy and happy and aren't too stressed out about everything. Remember, you can reach out to me, Remind, email, or Mrs. Steiner. We all would love to help. So I was wondering what the cavemen did for toilet paper. This is a actual image from a cave in France. It's about 10,000 years old and very intriguing. They do seem to have had toilet paper, so I don't know. It's up for you to figure out. Did they have it, and what they do? Okay, so I wanted to just walk through some more examples of this principle called relative dating, where we're not dating relatives. We're just trying to figure out if rock is older than something or younger than something. So no numbers, just older than or younger than. So there's two ideas we use. One is that rocks start flat, they start horizontal, and the oldest rocks are at the bottom. So down here, these rocks down here, they are all generally going to be older than the ones up here. But they didn't start tilted. So remember, they started flat. And if they started flat, we can actually tell which one's at the bottom. It would have been C. And then G would have been on top of C, A on top of G, and so on. So the oldest would be C, and then G, and then A, and then I, this like purple one, and then K, and then F. And then they were tilted. So they started out flat with C on the bottom making it oldest. Then they were tilted. So I'm actually going to add in tilt. Then they were tilted. Remember, they started out horizontal, started out flat. And then you notice there's this like squiggly line, and that's representing erosion. Right? You don't see any of those rock layers, C, G, A, I, K, and F. You don't see any of them above that squiggly line because they were all washed away by water, blown away by wind. So actually, after the tilting, there was erosion. Oh well, you get the idea. And then, let's look at layers B, H, J, and D. So again, they were deposited horizontally with the oldest at the bottom. So then we have D, that's on the bottom, so oldest. Above that is J, J is younger, and then H, and then B. So that's how you could solve a problem like this. We'll do one more example. And this one is a bit tricky. So we've got A, B, C rock layers, and then we have a fault or a break in the rocks, that's E, and then we have D here, and D is an igneous intrusion. So again, keeping in mind that all the layers started flat, except for intrusions. Intrusions don't start flat, and I'll explain why in a minute. But keeping in mind the layers start flat with the oldest at the bottom, then C is the oldest, and then B, and then A. Now the thing with intrusions is they are younger than everything they cut across, because everything they cut across had to already be there in order for the intrusion to intrude into it. So it's younger than A. See, it cuts across A over here. It's younger than B. It cuts across B over here. And it's younger than C. It cuts across C. So intrusion D happened next. Intrusion D. And now fault E, you see fault E here, that actually cuts across even the intrusion. It cuts across everything And if it cuts across something, it's got to be younger than it. Remember, all of these rocks, A, B, C, and D, had to already be there in order for the fault to break them. So fault E would be the youngest thing to happen. So there's just a couple of examples of what you're going to do on your lab. There's a challenge question, which is what actually you saw in the first video. It was with that one guy. He brought up this same image. It's a bit tricky because there's a lot going on, but just remember everything starts flat, so, and everything at the bottom is younger. So just to start you off, on the bottom here we have E, G, L, and C. Those would have started out flat, with E the oldest on the bottom. And then things afterwards, like they notice there's a fault here, H, and notice they're tilted. Those are things that would happen after they're flat. So give this a shot. One more thing, also note this big intrusion A. Remember, if it's cutting across something, it is younger than it. So it cuts across E, cuts across the orange, cuts across the pink, which is G, cuts across the green, which is L, cuts across the C, cuts across M, cuts across D, cuts across J. So A's got to be younger than all of those things. All of those other things had to be there in order for A to intrude into it. So give this guy a shot. Remember, you can reach out to me, email, remind, ask me any questions, and hope to see you guys soon.